Hi students, welcome back to the session. Let me consider the next content in the lesson, that is graphical representation of motion. The next content, graphical representation of motion. Representation of motion. So in mechanics, you know very well the many parameters are going to changes with respect to the time. For a moving body, many parameters are going to change with respect to the time. For example, the position of a body continuously changes with respect to the time. The body is going to cover the different distances in a different interval of time. And the body may have different velocities or speed at different interval of time. In general, we are making use of line graph to explain the many parameters which are related to the moving body, or else will determine the many parameters which are related to the moving body with the help of some suitable line graphs here. So the graphical representation of motion is a simplest technique or simplest method to analyze how the body is going to cover different distances in different interval of times, how the velocity of a moving body can change, and how the acceleration of a body can be determined, how the speed of a body can be determined, or else which kind of the motion the body can have, whether the body can have the uniform motion, whether the body can have the non-uniform motion, whether the body is moving with a uniform acceleration, whether the body is moving with what? Non-uniform acceleration. Many parameters which are related to moving body in mechanics can be explained by considering some important graphs here. The first important type of graph, what we are considering, that graph is called distance time graph. The first graph is a distance time graph. So this distance time graph is also called position time graph. The distance time graph is also called position time graph. In general, it is also called PT graph, that is position time graph for a moving body. The first graphical representation of motion, or first type of what? The graph which is related to the motion is distance time graph, or else we will call it as a position time graph. So how you are going to draw the position time graph here? To draw position time graph, change in position of a body should be taken along y-axis. Concentrate here. Graph should be plotted by taking change in position of a body along y-axis, and time is taken along what? X-axis. If the time is taken along x-axis, change in position of a moving body is taken along y-axis. Whatever the graph you are going to obtain, that graph we will call it as a distance time graph, or else we will call it as a position time graph. Or else the distance traveled by a given body, the distance traveled by an object is taken along y-axis, and time is taken along what? X-axis. What graph you are going to plot, that graph we will call it as a distance time graph. Then how you are giving the definition for distance time graph? A graph is plotted by taking distance traveled by a body along y-axis, and time is taken along x-axis. Whatever the graph you are going to obtain, that graph we will call it as a distance time graph. Okay, we can plot distance time graph for various types of motion. So what is the meaning of various types of motion? Sometimes the body may have uniform speed, or sometimes the body may have uniform velocity or uniform speed. Sometimes what happens? The body may have non-uniform speed. Sometimes what happens? The body may be in the state of what? The rest. We can plot distance time graph for various types of motion. So let me consider the nature of distance time graph for a body which is moving with uniform speed. What is the first case? I am taking distance time graph for a body which is moving with a uniform speed. My next question is, how does you say that? In what condition you say that the body is moving with a uniform speed? When does the body is said to be have the uniform speed? When the body is covering, when the object is covering equal distances in equal interval of time. If the object is covering equal distances in equal interval of time, then the object is said to be have uniform speed. If the speed of a moving body is uniform, the graph, which graph? Distance time graph or position time graph is a straight line. Concentrate here. What is the nature of distance time graph or position time graph? Distance time graph. This distance time graph is a straight line. Straight line for a body. For a body moving with which speed? Constant speed. If the body is moving with a constant speed, the nature of position time graph or a distance time graph is a straight line. So if I draw the nature of the graph will be like this. As I said, time is taken along x-axis. The time is taken along x-axis. I am taking time in second. Which parameter we are taking along y-axis? Distance travelled by the body. You know very well, generally the distance travelled by the body is denoted by S here. Distance travelled by the body is taken along y-axis. Time is taken along x-axis. Suppose if the graph is straight line, if the graph is linear, this graph is also called which graph? Linear graph. If the graph is linear or a straight line, which graph? Suppose distance time graph for a moving body is straight line, then what is the conclusion? We can say that the body is moving with uniform speed, or else the speed of a body is constant. So if the graph is straight line, definitely the speed of a body is constant. Let me take one simple example here. As I said you, if the body has uniform motion, that is, if the body has uniform speed, it is going to cover equal distance in equal interval of time. It is going to cover equal distance in equal interval of time. Say for example, I will take time along x-axis and distance travelled by a body along y-axis. So time is taken in seconds. Time is taken in seconds and distance travelled by the body, in this case I am taking in meter. Okay. Initially when the time is 0, that is 0 second, distance travelled by the body is also 0. Got my point? Next is when time is 5 seconds, when the time is 5 seconds, distance travelled by the body may be 20 meter. After 5 seconds, the distance travelled by the body is 20 meter. If the time is 10 seconds, then the distance travelled by the body is how much it is? 40 meter. Okay. When the time is 15, seconds, then the distance traveled by the body is how much it is? 60 meter. When the time is 20 seconds, then the distance traveled by the body is what? 80 meter. So look at distance traveled by the body in a different interval of time. Look at the distance traveled by the body in a different interval of time. Okay. From 0 to 5, how much is the time? Time is 5 seconds. The distance traveled is how much it is? 20. From 5 to 10, how much is the time? 5 to 10, the time is 5 seconds. How much further distance the body is covering? 20 to 40. 20 to 40 means in the next 5 seconds, the body is covering how much distance here? 20 meter distance. Then go for 10 to 15. 10 to 15, how much is the time? Next 5 seconds. The distance changed from 40 to 60. Means in the next 5 seconds, once again the distance traveled is how much it is? 20 meter. What it indicates? The body is covering equal distance in equal interval of time. Means after every 5 seconds, look at the distance traveled by the body. After every 5 seconds, distance traveled by the body is how much it is? 20 meter. Let me plot a graph now. I will plot a graph by taking time along x-axis. I am taking time along x-axis. The time is measured in terms of seconds here. Next I am taking distance traveled by the body along y-axis. Distance is taken along y-axis. It is in meter. Choose proper scale here. Time changes from 0, 5, 10, 15, 20. I will choose the proper scale here. First is 0. Then it is 5. Then comes 10. Next is 15. Next is 20. Okay. Distance traveled is taken along y-axis. Here I will take 20. Next comes 40. Next is 60. Next is 80. Now plot the graph. Okay. What is the first reading here? When t is 0, s is also 0. When t is 0, s is 0. Point lies here. Okay. When t is 5, s is how much? 20. When t is 5, the s is how much it is? 20. Point comes here. Okay. Point comes here. T is 5, s is 20. Then t is 10, s is 40. T is 10, here it is 40. 10, 40. The point comes somewhere here. This is the next point. Okay. Then next is when time is 15 seconds, distance traveled is how much it is? 60 here. When the time is 15, it is how much it is? 60. When the time is 20 seconds, the distance traveled is how much it is? 80. Okay. Join all the points here. If you join all the points, definitely the graph is, which graph it is? It is a straight line. You join all the points, the graph is straight line. Okay, should be exactly straight line. If you use a scale, definitely it will be straight line. Which graph is straight line here? Distance time graph is a straight line. Distance time graph is a straight line, or position time graph is a straight line for which type of motion? When the body is moving with uniform speed or uniform velocity. So next is using graph. Using which graph? Distance time graph. I will let you know how to calculate the velocity of a moving body. How to calculate the velocity of a moving body, or speed of a moving body can be calculated by using what? position time graph or distance time graph. The method is very simple. To find distance, velocity or speed of a body, you have to select any 2 points on the graph. You have to select any 2 points on the graph. I am selecting these 2 points. Okay. One point I will call it as A and another point I will call it as a B. One point is A and another is B here. Okay. From point A, that is first point, draw a line parallel to y-axis. Draw a straight line parallel to y-axis so that it should intersect with what? X-axis. Like this. From first point, draw a line. Draw a line so that it should reach to what? X-axis, and this line is parallel to what? Y-axis. One more line you can draw here. That line is of course this one. From same point, one line should what? Reach x-axis and another line should reach what? Y-axis. That is, whatever the lines you are drawing, one line is parallel to the x-axis and another line is parallel to the y-axis. This is for first what? The point. One more point I am selecting, and from this point draw a line so that it should intersect with what? X-axis. From the same point draw one more line and it should intersect with what? Y-axis. Okay. I got 2 points on x-axis, that is this one and this one, and 2 more points I got on what? Y-axis. 2 more points I got on y-axis. 2 points on x-axis and 2 points on y-axis. First point I will call it as a T1. First point I will call it as a T1. And second point I will call it as a what? T2. Second point I will call it as a T2. First point is T1 and second point I will call it as a T2. On y-axis, the first point what I am getting, that is I will call it as a S1. Because along x-axis we have taken distance, therefore I am labeling the 2 points as S1 and S2, and x-axis Y1 and Y2. Here S1. Second point what I have, that I will call it as a S2. This is S1 point, this is S2 point. Then what is the speed of a body? The speed of the body is given by what? Speed equals to, here the formula is S2 minus S1 divided by T2 minus T1. What is the speed of the body? The speed of the body is given by S2 minus S1 divided by T2 minus T1. Which is S2 here? Which is H2? 60. Minus, which is S1? That is 20. Divided by, what is T2? 15. T2. 15 minus, what is T1? That is 5. 60 minus 20, that is 40. 60 minus 20, that is 40. Divided by 15 minus 5 is 10. 40 by 10, it is 4. What is 4? 4 is a speed of a body. The speed of a body is given by 4 meter per second. So here, as I said, graph is a straight line indicating that the speed of the body is constant. What is the meaning of speed of the body is constant? You select any 2 points on the graph and try the same. You are going to get the same value as 4 meter per second. Conclusion is very simple. What is a distance time graph here? A graph is plotted by taking, a graph is drawn by taking distance travelled by the body along y-axis, time taken by the body is along x-axis, whatever the graph you are getting, that graph will call it as a distance time graph. If distance time graph is a straight line, or if the distance time graph is a linear, it clearly indicates that the velocity or speed of a moving body is constant. Velocity or speed of a moving body is constant. Suppose if this graph is not a straight line. What is the meaning when this graph may not be straight line? When the body is not covering equal distances in equal interval of time. Suppose if the body is not covering equal distances in equal interval of time, then I can say that the body is moving with a non-uniform speed or non-uniform velocity. When the body is moving with non-uniform velocity, definitely this graph will not be straight line. This graph will not be linear. You are not going to get linear graph. You are going to get curve. Instead of straight line, you are going to get a curve it is. So, definitely what is the feature of this distance time graph, you tell me? If a distance time graph for a moving body is straight line, it indicates that the body is moving with a uniform speed. If distance time graph is not straight line, it's a curve. If it is not a linear graph, if it is a curve, then definitely what it indicates? It indicates that the body is moving with a non-uniform speed. Let me take one example here. Which example? Body is not covering equal distance in equal interval of time. The body is not covering equal distance in equal interval of time. Say for example, at t equals to 0, the distance is 0. At t equals to 1 second, at t is equals to 1 second, distance traveled may be 2 meter. Okay. At t is equals to 2 seconds, distance traveled by the body may be 6 meter. At t is equals to 3 seconds, distance traveled by a body may be what? 8 meter. And at t is equals to 4 seconds, the distance traveled by a body may be what? 12 meter. So in this case, the body is not covering equal distance in equal interval of time. For example, 0 to 1, that is 1 second, it covered 2 meter distance. From 1 to 2, from 1 to 2, look at the value, 2 is changed to 6. From 1 to 2 means in the next 1 second, the body covered a distance of 4 meter. In the first 1 second, it covered 2 meter. In the next 1 second, it covered 4 meter. 2 to 3. 2 to 3. In the next 1 second, once again the body covered a distance of 2 meter. Then 3 to 4, the body covered a distance of what? 4 meter. Means, first second it covered 2 meter. Next 1 second it covered 4 meter. Next 1 second it is covered 2 meter. Next 4 seconds it will cover 4 meter, indicating that the body is not covering equal distance in equal interval of time. Then easily we can say that the body has non-uniform speed. In such a case, if you plot a which graph? Distance time graph, that distance time graph or position time graph is not a straight line. Let me see here. As I said you, distance traveled by the body, that is S in meter, is taken along y-axis. Time is taken along what? X-axis. Okay, I will choose the proper scale here, 0. Next I will use 1. Next is 2, 3, 4, 5, so on. Here I will take 2, 4, 6, 8, 10, next 12. Distance is in meter and time is in second. Plot a graph. When time is 0, distance traveled is also 0. Therefore, the point comes here. When the time is 1 second, distance traveled is 2 meter. 1 second, distance traveled is 2 meter. The point comes here. When the time is 2, the distance traveled is 6. When time is 2, the distance traveled is 6. Somewhere here. Okay. When the time is 3, distance traveled is 8. When the time is 3, the distance traveled is 8. When the time is 3, the distance traveled is 8 here. When the time is 4, distance traveled is 12. When the time is 4, the distance traveled is 12. Now join the graph. That graph is not a straight line here. Look at the graph. The graph is not a straight line. It is a curve it is, which indicates that the body has non-uniform speed. So this is how the distance time graph is taken for the body which is moving with a uniform speed and the body which is moving with a non-uniform speed. Okay.